The story of Earth's material formation is a journey that stretches from the dawn of the universe to the intricate complexity of the modern planet we call home. Understanding this history is to glimpse the grand processes that forged not just our world, but the very building blocks of life itself. Watch until the end. A surprise awaits you. Subscribe to the channel now so you don't miss out on valuable knowledge, and join me on the journey of independent scientists. It all began nearly 13.8 billion years ago, with the mysterious and cataclysmic event known as the Big Bang. In a fraction of a second, all the matter and energy of the universe exploded outward from a single, unimaginably hot and dense point. In the aftermath, the universe was a roiling sea of subatomic particles, heat, and light. As this primordial chaos expanded and cooled, it set the stage for the first simple elements to form, hydrogen and helium, within the first few minutes of existence. These elements would become the raw material for all future stars and galaxies. But the universe we know today is filled with a rich tapestry of elements, from carbon and oxygen to iron, gold, and uranium. Where did these heavier elements come from? Their origin lies deep within the fiery hearts of ancient stars. Over millions and billions of years, these stars fused hydrogen and helium into ever heavier elements, a process known as nucleosynthesis. When massive stars reached the end of their lives, they died in spectacular explosions called supernova, scattering their enriched guts across the cosmos. Each supernova was a forge, creating and dispersing elements that would one day coalesce into planets, moons, and even living beings. Fast forward to about 4.6 billion years ago. In a quiet corner of the Milky Way galaxy, a vast cloud of gas and dust, enriched by countless generations of dead stars, began to collapse under its own gravity. This collapse formed a spinning disk, at the center of which ignited the newborn sun. The leftover material in the disk didn't go to waste. Within this cosmic nursery, dust grains began to stick together, forming pebbles, then boulders, and eventually kilometer-sized planetesimals. Through countless collisions, these building blocks merged, growing larger and larger, until a handful became the planets of our solar system. Earth's early days were anything but tranquil. The young planet grew through violent impacts, accumulating more material with each collision. One of the most dramatic events in Earth's formative years was a colossal impact with a Mars-sized body, often called Theia. The aftermath of this collision was the ejection of vast amounts of debris into orbit around Earth, where it coalesced to form our moon. The energy released in this impact was so immense that it left Earth's surface a bubbling ocean of molten rock, a global magma ocean. As Earth began to cool, a remarkable transformation took place. Denser materials like iron and nickel sank toward the center, forming the metallic core. Lighter silicate minerals floated upward, forming the mantle and crust. This process of differentiation not only created the planet's layered structure, but also generated the magnetic field that shields us from harmful cosmic radiation today. The formation of Earth's crust marked the beginning of yet another chapter. Initially, the crust was thin and unstable, constantly reshaped by volcanic activity and relentless bombardment from space. But as time passed, the crust thickened and stabilized. Volcanic eruptions vented gases from the planet's interior, creating a primitive atmosphere rich in water vapor, carbon dioxide, and other gases, but almost devoid of free oxygen. Where did Earth's water come from? Scientists believe it arrived through a combination of sources. Some was released from the planet's interior through volcanic outgassing, while a significant portion may have been delivered by icy comets and water-rich asteroids that bombarded the surface. As the planet cooled further, water vapor in the atmosphere condensed and fell as rain, filling the low-lying areas to form the first oceans. By about 4.4 billion years ago, Earth had vast seas, a critical prerequisite for the emergence of life. The presence of liquid water and a dynamic atmosphere set the stage for the next great leap, the rise of continental crust. Over millions of years, complex geological processes, including melting, recycling, and the addition of lighter materials, gave rise to thicker, more buoyant continents. These land masses were fundamentally different from the dense, basaltic crust of the ocean floors, and their formation was crucial for the evolution of the planet's surface and climate. Earth's surface was, and remains, in constant motion. Thanks to the relentless heat churning within the mantle, the planet's outer shell fractured into gigantic plates. These tectonic plates drift atop the semi-fluid asthenosphere, colliding, pulling apart, and sliding past one another. Where plates meet, mountains rise, oceans open and close, and volcanic eruptions and earthquakes reshape the landscape. Plate tectonics not only recycles the crust, but also plays a vital role in regulating the planet's climate by cycling carbon between the atmosphere, oceans, and rocks. Life, too, contributed to the transformation of Earth's surface and atmosphere. The first living organisms, simple, single-celled microbes, arose in the ancient oceans. Over billions of years, some of these evolved the ability to harness sunlight through photosynthesis, releasing oxygen as a byproduct. Slowly, this oxygen accumulated, fundamentally altering the chemistry of the atmosphere and paving the way for the rise of more complex multicellular life. Today, Earth is a marvel of interconnected systems. The atmosphere, oceans, continents, and living things are locked in a delicate balance, shaped by eons of geological and cosmic processes. The crust beneath our feet is ancient and yet ever-changing, recycled through plate tectonics and volcanic activity. Water cycles endlessly from sea to sky and back again, nurturing life in all its forms. From the ashes of ancient stars to the rolling blue oceans and green continents, Earth's material history is a story of transformation, violence, and renewal. Every atom in our bodies was once part of a star, and the processes that built our planet continue to shape it today. In understanding the history of Earth's materials, from the origins of the universe to the modern world, we gain not only scientific knowledge, but a profound appreciation for the interconnectedness of all things and our place in the grand cosmic story. If you've watched this far, congratulations! You are truly a passionate scientific explorer, always persisting and conquering every challenge. Let's subscribe to the channel so we can keep on discovering together.